Hello guys, welcome to third lecture of the subject dynamics of machinery. Today we are going to learn two very important terms related to gyroscope as we are studying the chapter gyroscope. First one is angular velocity and second one is angular acceleration. Now you might be asked in examinations that explain what is angular velocity or explain what is angular acceleration, or it may be asked that describe in brief what is angular acceleration, or it may be asked that with a neat sketch explain what is angular velocity and how it can be represented by vectors. Any questions can be asked from this section. So let us first understand that what is angular velocity and angular acceleration. Now, what is angular velocity? Now, it is now what is velocity? Velocity, linear velocity means it's linear velocity. It is distance traveled by time taken. And what is acceleration or translational acceleration means a linear acceleration. It is the rate of change of velocity of any object. So, what is angular velocity? It is the angle moved in some particular time. That is angular velocity, right? Now, there is some misconception behind the angular acceleration, and that is people think that only the rate of change of velocity is angular acceleration. No, that's not true. Let me give you an example. If you are traveling in a car at particular speed, say for the example at 30 kilometer per hours, and you take a turn and you slightly move sideways, right? What is that? What is that effect? That is that is called the angular acceleration, right? So like this, if you change, now remember this is very important. If you change the direction of the spin axis, accelerations comes into picture, right? So remember this, that change in magnitude or direction in on any rotating object can create the angular acceleration, right? So, if the concept is clear, let us start learning what is angular velocity and how it can be represented by vectors. Again, let me remind you that change in magnitude or change in direction of any rotating object can create acceleration. Okay, so it is not necessary that only change in magnitude can create the angular acceleration. Okay, so let us move towards angular velocity. Uh, so there are a few things to note over here that let me show you a figure. Yes. So in this figure, a rotor or disk is rotating at omega angular velocity, omega radians per second angular velocity. AB is the shaft or rod on which the disk is rotating clockwise, viewing from the A. This is very important. It is rotating clockwise when viewed from the side A to side B. Okay, so it is rotating clockwise. So this velocity can be specified by uh, a few things like magnitude of the velocity, at how fast or slow the disk is rotating, that is omega radian per second. Second one is the direction of the axis of rotor, means the axis of rotor is AB, right? This is the axis of rotor. So it may be on some particular axis in space, means x, y, or z. So that is the direction of axis of rotor. Next is the sense of rotation of the rotor, means it is rotating clockwise or anti-clockwise, right? That is called the sense of rotation. So these three things uh, are required to specify the angular velocity of any rotating body. Now, if you want to represent the angular velocity by vectors, it is a vector quantity because it is having magnitude and direction both. So that's called the vector quantity. So that's why, because it is a vector quantity. So what if we want to represent this angular velocity by vectors? First, we need to understand the right hand screw rule, in which direction the arrow will be pointing. So let's cover it later in few minutes. First, the vector can be represented by the magnitude of the velocity, and that is represented by the length of the vector, means how large sorry, how long or small the vector is. It is dependent on how fast or slow the rotor is rotating. Means if the rotor is rotating at 500 rpms, the length will be more than the rotor rotating at 200 rpms. Okay, the length of the vector will be smaller. Now the direction of axis is parallel, means in the same direction of the rotor, means the rotor is rotating on shaft AB. So on that particular axis we assume that the vector is placed on that shaft. Okay, that is the axis of the rotation in that particular at that place the vector is placed. And third one is the sense of rotation. Now it is important that in which at which end of the vector you will put head of the vector. It is decided by the right hand screw rule. Now don't confuse this right hand screw rule with the right hand thumb rule. Okay, that is for the gyroscopic effect. So what this says that if assume that the screw is placed such a way that the disc represents the head of the screw and the end B represents the end of another end of that screw. Now what if you rotate that screw clockwise, means in the direction of the rotation of the rotor, that screw will go inside. Okay, inside means at the side of B. So you need to put the arrow on B because the screw will move that side. Now imagine that if the disc is rotating anti-clockwise, so you need to assume that you are rotating the screw anti-clockwise so that the screw will move outside, means towards A. In that case you need to put the arrow on A like here. Okay, but now the case the rotor is rotating clockwise. Assume that the screw is put sorry, the head of the screw is put over here and the end of screw is put over here, so that the this vector is represented like this. Okay, because of the clockwise direction, so the screw will move in this direction. Now if this rotor is rotating anti-clockwise, like this represented by the dashed line, so you need to assume that the screw is rotating anti-clockwise, so it will move this direction, in this direction outwards. So this vector is represented by this dashed line. Okay, likewise you are representing the vector of angular velocity. So again three things that first one is that magnitude of velocity is represented by the length of the vector, means if the disk is rotating very fast, you are keeping the length of the vector likewise, means the higher the speed, the longer the length of the vector. The lower the speed, the less, the shorter the length of the vector. Second one, the direction of axis of the rotor. Okay, so it is rotating in this the disk is rotating in this shaft, so that the vector is represented parallel to this shaft, means we are assuming that the vector is somewhere in the center of this shaft. The third one is the sense of rotation, means clockwise or anti-clockwise according to right hand screw rule, not right hand thumb rule. So hope the angular velocity is now concept of the angular velocity is clear.